In this video, let's work through algorithm 1, the number of paths. So to summarize how we do that, here are the steps, but it's going to make much more sense when we go through that as an example. So we need to work from start to finish, obviously. And from the start, you work in the direction that the arrows are pointing, and we label each node with the number of paths that can get there. So the node, the dot, how many ways were there to come into that point, into that vertex. And then the value of the label at the finish of the node, that's the total number of paths. So we're sort of adding things up as we go till we get to the very end node, the vertex there, and that would be the total of number of paths. But let's obviously put this into practice. So if we're asked to determine the number of paths from node A, here top left, to node Z, bottom right hand corner there, for this network. So I would advise you to draw this out yourself and add them in as you go so that you're doing the thinking with us. So starting at A, obviously there are no edges coming into node A, so we can put a 0 there. If your diagram doesn't have circles to put them in, you would put the number just near the node, near the dot there. Now, sometimes it's quickest to go, well, to start with, to go along the edges. So we're going to go labeling the top edge here and then the side edge here. Each of those edges coming out from A is what I mean. So how many ways were there to come into this node? Following the arrows, well, there's actually only one. It's through this path here. These other edges go out from this node here. So moving along the diagram, how many ways to come into this node? Again, only one. That happens on the edges. There's often only one way to get into them. So this one over here would be a 1. Notice we're not adding the numbers up or anything like this. We're looking at each node individually and saying how many ways are there to come into that node. Now we're going to come down the side here. What do you expect for this one here? Another 1. And here, how many ways to come into this node? Just the 1. Now, moving along, we usually work from left to right, top to bottom. Here, how many ways to come in here? 2. And notice that the way we did that, we were adding up the numbers here, 1 and 1. 3 for the next one here. This is the addition of there's one way to come into this node here from the top, and there are actually 2 ways to come in from the left-hand side to get that 3. Notice it is not the number 2. Just because there's one edge there and one edge there, we don't put a 2 there. We're adding up the numbers that flowed into it. Not every number beforehand, just the ones that flowed into it. So therefore here, adding up the numbers that flow in, a 3 flows in and a 1 flows in, so this would be a 4. Along the bottom row here, what are the numbers that flow into here? So there's 2 lines, but along this line is a number 2, and along this line here, this edge is a number 1, so we should put a 3 here. And of the 2 ways of coming into this node, adding up the numbers that are on those paths, we would get a 6, and therefore the total paths here, the number of paths from node A to node Z with no restrictions is 10. So what that represents is the 10 ways to get in. So here would be one way, another way would be like this, 2, 3. So that's a way of working out all those possible ways without you having to try and remember them, because 10 might be able to be managed to memorize, but once it starts to get bigger, it's not something you can hold in your head, so you need to have a technique of working out the number of paths. Now, 2 more variations on this. What if you're told to avoid a node? So this section here, we cannot go through X. Therefore, how can we get to Z without going through here? You can probably start to imagine the different pathways that you could go. What about the ones that go near X? But don't go through it. So, similar technique. First suggestion, put a 0 where you can't go, because obviously then there's no numbers coming out from that, because we can never go through X, so you can never stand there. Next, start again at A, always putting a 0 where you are because you had no edges coming in to you there. Same technique, we're going along the edge. 1, 1 and 1 along the side here, because there's only one way of getting in, and then down the side here, 1 and 1. Now let's work our way through. This node here, adding the numbers that came in, we get a 2. Then, obviously we've already done the X. Adding the numbers that come in here, there was a 1 plus a 0, and so it's the number 1. Yes, there are 2 arrows that go into it, but we're not putting the number 2 because we're adding the numbers. There are 0 ways that you can get into this node here from the left. You can only get into this node from above. The next one here, adding the numbers. 2 plus 1, 3. Adding the numbers. 0 plus 3 is 3. Adding the numbers to get a 4. So the number of paths from node A to Z that avoid node X is 4. Only 4 ways you could get here. What's the flip side of that? That's avoiding it. But what if you have to go through it? What if it's going from one house to another and you have to stop off at the shop here at node X and it's forcing you to go through there? How do you work that out? Very similar again. But this time you have to go through X. So the technique to start with then is not to put a 0 or any number with X, thinking about the spots where you can't go then. So if you're imagining some paths that come through X, coming in from the top or coming in from the side, which nodes are you never going to be able to get to because of the direction that the arrows are, because you can't backtrack. So these nodes here, there's no way that you could come through these and still get to X because the direction doesn't flow that way. So put a 0 to start with in the ones that you can't get through. So that's 3 now. And now we work on it like we have before, starting with 0, going along the edges, 1 and 1, coming down this edge, 1. Now moving along, adding the numbers together to get a 2 here. Same thing, adding the numbers to come into X, so 3 ways there. This one here, adding the numbers, a 3 plus a 0. Again, don't worry the fact that there's got 2 edges coming into it. This edge here, on this occasion, has a 0, so it's a 3. Down here, 3 plus a 0, we've got 3, and 3 plus 3 is 6 to get to Z. So the number of paths from node A to Z that passes through node X is 6. So there are 6 ways you could have gotten to Z going through X. Just a little side note, this is 6. Do you remember what the example number 2 was, where you had to bypass X and you couldn't go through? That was 4. 6 and 4. Do you remember what it was on example 1 of how many paths in total if there were no restrictions? It was 10. And that's exactly what should happen. Those two numbers should complement each other, the 4 and the 6, of if it's relating to a particular node where you must go through or must avoid. So if you don't get those two adding up to be the total number, you've done something wrong in your calculations. I hope that makes sense. Here's some questions for you to do now.